Hopefully everything works. OBS just had an update and I had to read thing. Sound, video, capture, all of the things new. So hopefully everything works. A little bit panic. So, folks who are here, what kind of stuff would be helpful as a place to start, whether it be on any part of the review or alternative question styles, whatever. The questions on the review packet we have, I mean that's fine with me. Good with that. Wait, bailing like no multiple choice at all. Yep. That is what bailing is. I just don't want to write it. Very good. I have a lot of doctor's appointments. I just don't want to deal. Okay. Actually showing my. Oh yeah, I'm like. Yeah. Other questions on the review packet specifically for the free response? Yeah, I mean, kind of everything is. I mean, even if you look at the multiple choice here, like 4 and 5, these are differential equations you solve, and this is what between half and 3/4 of what one of the free responses is. So really all these are is at bats for that sort of thing. This sort of thing is like practice for split fields and identifying them, which could show up on the free response. This is a full free response question right here that is on the review. And then if I hop over to the chapter 7 review, what is the chapter 7 review on? Area, volume, revolving, cross sections, stuff like that. Oh, like this question. So while it's not a free response question, basically, if you can do this question, you can probably do the free response that's coming on the tests. And then these are actual response questions, although this one's the same as the. Okay. I guess it would be question 13, but it's not numbered. Question 13. Oh, you mean this question? I assume this thing is in 13. I'll wait for confirmation from you, and I'll look at number 4 on the 3rd page. I would assume that that's this question. Solve the differential equation? Or, wait, 3rd page. That could very much be this question. Oh man, I have no idea. 4C on page 2. Oh man, I am really in over my head right here in terms of figuring out what everything is. Ah. Oh, it is. Okay. So I have at least confirmation on one of the questions. Probably would help me. All right, so this one was a little bit weird because there's like a top and a bottom curve that are both their own things. So I'm just gonna write expressions if I do any of these. I'm gonna be really lazy and call this f of x. Call this of x. What about potatoes? Ah, I got you. Thank you, sir. write the expression for the area of region R1. Okay, cool. Then I integrate from 0 to 2 of top curve minus bottom curve x. Sick. Find the volume rotating around the x-axis. Cool, that's this direction. That's kind of the easy one here. Because if we rotate around this line, our outside radius is just the height of f of x. Our inside radius is just the height of g of x. So it's just same bounds as the area, pi, and I just do f of x squared minus g of x squared x. Oh man. My video here is not live. Alright. Thinking I'm messing up, but so that's around the x-axis. Around y equals -2, actually pretty similarly difficult because we're just down below here. All it's going to be is this exact same equation that I did up here, except it's going to be 2 plus f of x squared and 2 plus g of x squared. So it's actually exactly the same as the previous one, except 2 plus inside there, those two. And then rotating around the y-axis, that's where things get a little bit ugly, because you actually have to solve these equations for what x equals, because the y-axis, you want to get it in terms of x. So you had to get like inverse cosine of y over 5, pi over 6x, and then you just divide by pi over 6, 6 over pi. It's this awful thing. That is what x equals. And then down here, multiply 10 to the other side, square root. So the square root of 10y equals 2x plus 1. And then we just subtract 1 and divide by 2. So it's the square root of 10y minus 1 over 2. So now I'm going to do that lazy thing, FG, H and I. Sure, we'll do H and I. H of x, or H of y, rather, is this thing. And I of y, is that bad? T-I? I'm not sure. H-I-J. And then, so now that I have these two equations, all I'm going to do is I'm going to integrate from 0 to 2.5 of the first equation, which is this one, the bottom one that goes from 0 to 2.5. Thing gets cut in half. So of that thing squared, root 10y minus 1 over 2 squared. And then I'm going to add the integral from 2.5 to 5 of the top thing that I rewrote there, which is, why did I just write it again? I just wrote, whatever. Of h of y. I'll be lazy this way. And I forgot pi's. Potato. There we go. That looks clean. What are the chances of inverse trig on the test? Well, to be honest, inverse trig doesn't add a whole lot of difficulty to this question. All you have to know is that it's what undoes cosine. Because at that point, because it's a calculator-allowed question coming on the test, you just type this crap into your calculator, and it would give you an answer. So, like, the inverse trig of this question doesn't actually impact anything calculus. It's just the annoying part of solving for y. So yes, inverse trig absolutely could show up, but you literally just need to know how to type it into the calculator and get it. With volume, when it's around the y-axis, it's in terms of x, and when it's no, that's exactly the opposite. Exactly the opposite of that, Nicole. So I'm gonna head to Potato Land. Or should I drop off at this 4? I feel like I should drop at this 4 because I think this is the one that Lucas brought up. If you separate variables, you get dy over 7 minus y equals x. How do you type it into the... that's a question I need a calculator. I have Desmos. So if you integrate this, probably find some way to emulate graphing calculator. Anyways, if we integrate this, it's like the one we did in class, where because this is the negative y, we have to get a negative natural log of 7 minus y for like u substitution, chain rule things. X plus c. And then you move the negative to the other side, like so. And then you e both sides. Get c, the negative x equals 7 minus y. And now you're chilling. It matches one of these real quick. You just add the y that tracks this thing. That one. I never said I'm good with letters. So yeah, one of the nice things about the way we do volume in this class, and actually why okay, so there's 3 ways to do volume. There's cross sections. There's revolutions, like disc and washers. And then there's shells, and this is the third way. The reason why I don't teach shells until after the AP tests is because for both cross sections and revolutions, the variable they bring up, like perpendicular to x, you use x. And if you reflect over the x-axis, you use x. It's very logical here. If the variable is x, you use x. If the variable is y, use y. In shells, it's actually the opposite. So the thing you brought up, that's true in shells. But we don't do those until afterwards, just so I don't confuse people. It's way easier to remember that if x is mentioned in the question, to use x. And so I hope that's something we can remember going into the damn thing. Double free response. Hopefully that was the right 4 for Lucas. I'm gonna assume it was, but I'm also maybe wrong. Maybe it was this 4. Whatever, I did a Diffie Q. So that means I want to go to the potato question. Alright. So, for the potato question... and yes, I can do that one next, Rachel. Okay, so in the potato question, the first thing to do is have you write a tangent line. So all you have to do is plug in the value at t equals 0, which is 91, into this equation. Find the slope. You get dh equals negative 1/4 times 91 minus 27, which is 64. So it's negative 60. And then you just do y equals negative 16 t, because t is our variable, plus 91. Normally I do point slope, but this is literally the y-intercept. So I'm just going to go straight to slope-intercept. And then you just chuck a 3 in here to get your approximation. Chuck a 3 in, you get 43 degrees, negative 48, 91. That was the right 4. Oh, sick. Second question here. So hopefully the first one was like sort of family friendly. Algebra there. For the second one, it very similar to the one I did in class today, which is find the second derivative. So if I find the second derivative, it is derivative of this equation is just negative 1/4 ht. Capital H. And then dh, so the reason why it's this is the derivative of h minus 27 is just dh dt, and then we multiply it by negative 1/4. And then because dh dt is negative 1/4 h minus 27, I plug in that here, a negative 1/4 h minus 27. And so negative 1/4 times negative 1/4 is 1/16 times h minus 27. And this is what the second derivative equals. So now what I want to do is determine whether or not it's an under or over estimate. So what you do is you take the fact that it says that the internal temperature of the potato is greater than 27 degrees for all times for t is greater than 0. So I know that this inside of this parentheses is going to be positive. And so I know the whole thing's going to be positive because there's a positive number out front here. So I know I'm concave up. If I'm concave up and I have a tangent line, if I drew that better, my tangent line goes below the curve at all points. I should try to draw it better. There we go. So I know that my approximation from part A goes under the curve because it will do that for every concave up graph, like this one. So this would be an underestimate. I have a face cam now. Yep. Thanks, COVID. All right, so our last one says for t is less than 10, an alternate model, blah, blah, blah. So basically we get a new differential equation here. And based on this model, what is the internal temperature of the potato at t equals 3? This is actually solving the differential equation. So we have this new differential equation. If I separate variables from that differential equation, what I get g over g minus 27 to the 2/3, just dividing this term over to this side and putting the dt over on this side equals negative dt. Right side's an easy integral, negative t plus c. But the left side's kind of a pain in the butt, so we have to flip this homie up, actually handle it correctly. So taking the negative, or taking the positive power on the bottom and making it a negative power on top. Now I could raise the power by 1 and divide by the new power. Why am I doing this at an angle? No? Yeah, maybe it's not comfortable. I don't know. Anyways, so we can multiply 1/3 on both sides and get g minus 27 to the 1/3 equals negative 1/3 e plus a new c. Then we cube both sides and we get g minus 27 equals negative 1/3 plus c cubed. And then we add 27, so g equals that stuff cubed plus 27. And now I just plug in the initial conditions, 0 and 91. So 91 equals c cubed plus 27. So 64 equals c cubed. Oh, yeah, I plugged in 0 here, so this term went away. So c is 4. And now we're being chill. G equals negative 1/3 plus 4 cubed 27. Bam. Equation. Now check a 3 in here for the final bit. And we get negative 1 plus 4 is cubed plus 27. So it's 27 plus 27, where 54 degrees is our thing from this model, which if you compare to part A, I got 43 degrees up here. It turns out the fact that I said this was an underestimate is now borne out by this answer to that model. Okay, isn't the second derivative negative? I'm confused. No, it's not, because it's negative 1/4 dHdt, but when you plug in dHdt, it's also negative. And you get negative 1/4 times negative 1/4, which is a positive 1/16. And the temperature H is always greater than 27. It says so in the question up above. It says right here, temperature is always greater than 27. So if the front number is positive and the parentheses is always positive, then the whole thing's always positive, and we're always concave up. That. Always, always, always. So hopefully I didn't go through that too fast. People were able to follow. I actually think it's kind of cool on the AP test what a huge variety they have in types of differential equations they have you solve. If you go and look up more questions, they're kind of all over the place. There's all sorts of different style-y ones. Some of them have exponential sort of patterns, like sort of Kex things. Some of them don't. Some of them have that on both sides, and you end up with like the 1 over x plus c sort of deals. Uh, I think it's really cool that they have such a variety. Uh, so what's unfortunate for you is it could be a little bit more variety. I have a large stable of kinds of questions I can choose, but as long as you can do the algebra, you should be chilling. All right, so the question I got that came before that, could you go over one on the chapter 7 work? Yeah, that's bopping over. Question 1. Oh, I wrote all over it. Oh, eraser, fill all this stuff. All right. Find the volume by rotating an ellipse around the x-axis. So this is kind of a weird question. So first of all, for ellipses, this is not how we like looking at these. We actually divide both sides by 9. Get x squared over 9 plus y squared equals 1. Generally how we look at an ellipse. So I know the x radius is 3, the y radius is 1. So I know it's longer this way than it is tall. And I'm rotating it around the x-axis. So the other thing I know is that these parts are going to be exactly the same. So really, I'm kind of taking the ellipse and only rotating it 180 degrees, because the top part will rotate over one side and the bottom part will rotate over the other side. But how we actually handle this is we basically pretend the bottom part doesn't exist, and we just rotate the top part around 360 degrees. So if we do that, we're just going to solve this equation for y. So I was closer here. This is kind of the first step of doing that. I'm going to subtract the x squared minus 9 over to the other side and then square root. And instead of getting plus or minus, since I just want the top part, I'm just going to get the positive 1 minus x squared over 9. And now that I have this, I'm just going to do from -3 to 3. Again, the benefit of knowing how the ellipse equation works and knowing the radiuses like this is I know it goes from -3 to 3. It's pi because we're revolving, and our radius is just the height of this square root function. So it's going to be the square root of 1 minus x squared over 9 squared x. And the square root and the squared cancel. So when I integrate this, I just get x minus x cubed 27, plugging in the bounds -3 and 3. And if you're thinking this, you actually could be really lazy here and just integrate from 0 to 3 and multiply by 2. That actually checks out because this thing is perfectly symmetrical on both sides. Just double that. But I'll keep going with the -3 to 3 for funsies. So pi times, if I plug in 3, 3 minus 1, cubed is 7. And minus pi times plugging in -3, get -3. And if I plug in -3 here, it'll be +1. And so, surprise, these two parts are the same. 2 pi plus 2 pi is 4 pi. Hopefully that made sense. In terms of process, a little bit of conics review from calc. That's where you do conics. Anything else that people have questions about? That'd be a fair question. Could I do the donut question? Or, sorry, free response? I could do a donut question. Fun. Kind of like the donut question, which if you don't know the donut question, if I give you a circle and make you reflect over the line, go into 3D. Donut. Lines. Okay, cool. That's definitely something I could ask. It's probably a tad beyond the pale, but it would be an interesting question. I wonder if there's an equation for saying my bit rate's bad. 1,000. I think everyone is just sad in chat. Why? I shortened the test by like half. Why are we sad? Is that like a reason to be happy? If everyone's sad, that mean I can just I'm already I have like other questions prepared because I just opened up AP Calculus free response, opened up 2010B, and look, I found questions that are very similar to what's coming at us. Like this one is exactly the format that the test is likely to be. Area, volume, volume, cross section. Pretty easy to find these. Donut. There's got to be an equation for the volume of a donut, like an actual like one you can look up on like Wikipedia or something. I don't actually know that, but it would be cool. How many free response do we have? See these questions right here that I just pulled up randomly? This plus this, that's the test. Literally, this, a differential equations one, has like a slope field, asks you some weird question, particular solution, and this. Want me to do the donut question? Donut question. Here's my donut. X squared plus y squared equals 4. I'll rotate it around. X equals -4. So it has a radius of 2. So it also height of 2. And you notice something weird when you look at this one. Its inside and outside radius are both the circle. However, if you solve for x in this equation, x squared equals 4 minus y squared, x equals plus or minus the square root of 4 minus y squared. What's special about this is the outer radius is the positive one of these things, and the inner radius is the negative one of these things. Why did I call them outer and inner? Why didn't I just call them big R and little? Big R and little r is roughly these distances. It's not quite these distances because I also have to do 4 plus 4 minus y squared. So my big R would actually be 4 plus the x coordinate of the positive one, which is square root of 4 minus y squared. And my little r would be 4 minus the square root of 4 minus y squared. And now that you have this, it's just the integral from -2 to 2 pi and big R squared minus little r squared y. Like these. That's the donut question. So really, it's actually not beyond the pale. It was quite reasonable and quite similar to the question Rachel asked me about. I'm so confused by Nicole's interactions. Could be work through that one. No. You answer your own question? Could be. Sounds like people are chilling. Maybe. Besides Nicole, who is asking questions that Nicole is answering. Time for Mr. Kennedy to go sit on his chair. Current viewers is dropping. Oh, the first example for your response. Oh, you want to see a volume one. Probably not going to solve all these all the way out because you get a calculator on the test. And no, this is actually a calculator. No, we chilling. Yeah, this has a wonky shape. True that. True. But okay, so if you want to find the area, all you do is 6 minus height of the natural log, homie. And because it's x that we're like integrating across, it's from 0 to 2. So top curve is 6, bottom curve is curve. And that's all you have to do to deal with the whole fact that it's kind of a janky section there. For, let's say, for part B, also is, for part B, it says revolve it around y equals 8, so up here. So that's my big R, that's my little r. Little r is super easy, it's 2. So I can set this homie up right now. 2 squared is my little r. But my big R is a bit of a pain because it's going to be 8, the line I'm revolving around, minus the height of the curve, or ln minus x. So that's what I got to plug in here, 8 minus 4 ln of x, and that's what's squared, minus 2 squared x. And again, y equals 8 is parallel to y equals 0, or the x-axis, so we use x to solve that question. And then the last part is we get to stay on the x-axis, and we're doing square cross-section, so all I have to do is integrate side squared, and it's going to be dx. So all I got to do is figure out what side is, and integrate from 0 to 2. And luckily, side length is just top curve minus bottom curve. So it's literally just this thing. So that's what I plug inside my squared. That's my side length, distance curves. And look at that. That took me like 2 minutes. And then the remaining 13 minutes could be spent plugging these into your calculator and getting what these answers are. Because you don't know how to integrate natural log. So this is straight up a calculator question. So y-axis, you use y bounds and y variables. Yep. X-axis, use x bounds and x variables. This was a really actually easy free response because you got to use x for all of them. Yeah, if you had to use y, it kind of would have sucked a little bit because you'd have to do this section differently than you do this bottom section. You'd have to integrate differently from wherever this intersects, right here. What is that? 4 ln of 3? That's what that height is? Yeah. You'd have to integrate from 0 to 4 ln 3, and then from 4 ln 3, 6, if you went over the y-axis. That would have been less chill. And you would have had to add these integrals together. That part. When you scroll up, your webcam just blocks what you wrote. Oh, that's good. I didn't catch that until too late. Here, let's just shrink my webcam. Add job webcam. Alright, I'll let that pause on the screen for a minute, and then I will pop down here, because I think Rachel said, wait, so you basically add how far away x or y is from 0, and that's how much you add. Yeah. Basically, the distance between the x or y axis. So if you're parallel to the y axis, and you just take the distance between the y axis and that line, and that's what you end up adding to those. Or if we were over on the other side, subtracting. So yes, it is in relation to the x or y axis. What this number? Good observation. To clarify, if we do the shortcut thing on the effort kit, the R thing I did here, this is too lazy. This is too lazy. If you said that this is f of y and this is g of y, here, then you could do this. You could do pi negative 2 to 2 of f of y squared minus g of y squared y. This would be legit. If you said that f of y is this and g of y is this, like so, then that would be something that is allowed. Hopefully that clears up what Von should was saying. Questions out of order. Ove. Wow, I went up to 13 concurrent viewers. Who knew I would go up? See this chart. Pretty epic. Look at that. 14. We'll cut in and out all the time. Wowzer. Always tells me my bit rates. Hi, Will. I see you. Yeah, so no multiple choice. This is Will Anderson. Isn't that like Yojit or something? Anyways, I'll see first period people tomorrow. I noticed first period people asked most of the questions today, with the exception of Rachel and Lucas. But maybe the future people will benefit from seeing this and seeing me slave through a bunch of questions. And I wish you the best of luck tomorrow or Wednesday. I've not written the ones for Wednesday, but I know the ones tomorrow are cookie cutter. They're not going to surprise you. They're not evil. Oh, it's not Yojit. Oh well. Please help us. I did. That was the last 40 minutes, sir. I need to go rest my arm. My arm hurts. Handwriting is very hard for me. Have a nice night, y'all. Heard Yo Rizzler. I'm in your fourth